Good morning, and welcome to the University of New Hampshire's Institute for the Study of Earth, Oceans, and Space. My name is Harlan Spence, and I'm the Institute Director. At the Institute, we refer to it as EOS. EOS is a university institute at UNH, which makes it an official academic unit, which means it's like a college, but with a focus on interdisciplinary research. It has sub-elements like departments in a college, and they are listed there. The Earth Systems Research Center, the Ocean Processes Analysis Lab, the Space Science Center, the Center for Coastal Ocean Mapping and the Joint Hydrographic Center, Center for Acoustics Research and Education, and the School of Marine Science and Ocean Engineering. Each year, we do annual expenditures of between $40 and $50 million per year, mostly funded by NASA, NOAA, the National Science Foundation, and Department of Defense. We have approximately 100 principal investigators who lead these investigations. Overall, I would say we are world leaders in three primary areas: climate science, ocean mapping, and space science, which I'll talk about next. The Space Science Center is a remarkably strong program at the University of New Hampshire. We have involvement in 25 active space missions. We're involved in all four of NASA's science areas within its science division. We have leadership on almost 3/4 of all missions in the one area of the Science Mission Directorate called heliophysics. In our fleet of active spacecraft missions aloft, we have 40 spacecraft. And if you add up all the years that they've been in orbit, we're over 560 years. Over the arc of time, from 1960, we've had approximately 50 total UNH space missions and that same number of balloon and rocket launches. Looking forward, we have a lot more opportunities with in-development programs listed there and future opportunities, and we're always looking for new business partnerships. When we think about the kinds of things we do and the excellence of our program, it's really gratifying to have people like the NASA administrator, Jim Bridenstine, here. He was a former NASA administrator most recently, visiting with Senator Jeanne Shaheen, learning about our program, both programs that are active and those that are in development. In terms of what I do, I'm a space plasma theorist, a physicist. I'm a theorist, a modeler, and do experimental work. And here's an array of the kinds of instruments that I have built over the course of my career, both at University of New Hampshire and at prior institutions. And they range in size from instruments that go on satellites that are really quite big, maybe 6 feet in diameter, to a CubeSat, which is literally that size, and that's the lower right-hand one. So we look forward to learning more. And we welcome you to UNH. Here's a picture of some of our folks at the launch of the magnetospheric multi-scale mission several years ago at the Kennedy Space Center. Up next, we have a little virtual tour of the Space Science Center where you can learn more about the specific related resources and capabilities there.
This is Morris Hall on the University of New Hampshire campus, home of the Space Science Center. Numerous past NASA missions have been managed, developed, and contributed to here at Morris Hall. Our scientists and students have been involved in instrument design and data analysis for more than 30 space missions over the past 60 years. Equipment built here will go into space on rockets or satellites to study the aurora borealis, the Earth's magnetic field, the Sun-Earth connection, high-altitude molecular flow, and more. Here we have the UNH Space Science Center, Fabrication Laboratory, and Environmental Test Facility. The Space Science Center has 2 NASA-certified technicians. After proposal and design, the parts come to this area for the first stage of assembly. Circuit boards are populated, cabling is attached, and detectors are assembled. If required, epoxy and coatings are applied in the polymerics room. Everything is cleaned using a 3-phase ultrasonic cleaning facility before going into the Class 10,000 clean room for the next stage of the project. In the clean room, assembly is completed and tested on the bench to verify proper operation. Inside the clean room, there is a Class 100 ultra clean area. Once successful, the device under test goes through the double doors into the large thermal vacuum chamber, where air is pumped out and the temperature is raised and lowered to simulate space. The chamber goes down to -40 degrees Celsius and up to 80 degrees Celsius, and produces vacuum of 1 × 10 to the -7 torr. The center also has several other thermal vacuum and thermal chambers. Testing is performed in the thermal vacuum chambers to verify that instruments are tested thoroughly down here on Earth in a simulated space environment to give scientists confidence that the mission will continue to generate data in orbit. Here you see the RFI, EMI, anechoic chamber designed to completely absorb reflections of either sound or electromagnetic waves. UNH uses this shielded chamber to filter out background electronic noise so that sensitive electronic equipment can be tested. Finally, we have the machine shop that has created mechanical parts for numerous missions over the years. Here we see a variety of machine tools including numerically controlled mills, lathes, saws, and drill presses. The machine shop includes an assembly area and inspection equipment for verifying precision tolerances. Thank you for touring the Space Science Center at the University of New Hampshire.